Hi friends, welcome to EK lectures. In this lecture, we are a random walker travels along one-dimensional discrete lattice. So minus n plus 1 extra up to 0 and again extra up to n. By putting random steps of length 1 unit. So from 0 to 1, it is 1 unit. Okay. Towards left or right. So the random walker has two probability, either left or right, forward, backward. If the initial position is 0, then the probability of finding the walker at 0th position in 6th step is, that means total number of steps he is taking is 6. And what is the probability of finding the walker at 0th position? That means effective step is nothing but where the position is 0. That means he is not taking any steps. That means effective step is 0. Now what is telling is, a person is standing at A, the random walker. He is taking some steps back and forth towards the positive direction and negative direction, or towards left or right. Then after taking n steps forward and backward, he is in the same position, 0th position. So initial position is 0. Let me call it as A as 0. Then after taking n steps also, or let me write in terms of this question, after taking 6 steps, the walker is at 0th position. Which means what? If he has taken 3 steps forward, he should take 3 steps back. Okay. Now coming to some ideas about random walk. If n1 is the number of steps forward, let me, instead of forward, you can write with respect to this question, you can write it as towards right. n2 is the number of steps backward. This is towards left. Then total number of steps is nothing but n1 minus n2, which is equal to m. So net steps equal to what? 0 with respect to this question. Now what is the total number of steps? n1 plus n2, which is equal to capital N, which is nothing but 6. That means after taking 6 steps, the net steps taken is 0. Now the probability of reaching destination which is m step away by taking n step. That means total number of steps he has taken 6. The effective step is 0. He is m step away. How much? M equal to 0. Then the probability Pn of m. What do you mean by Pn of m? Probability of reaching the destination which is m step away by taking n step, capital N step, is capital N factorial by n plus m by 2 factorial into n minus m by 2 factorial into 1 by 2 whole to the power n. So that is equal to, what is n? 6 factorial. 6 factorial divided by n plus m. M is 0 here. So 3 factorial into 3 factorial into 1 by 2 whole to the power 6. So this is nothing but 6 factorial by 3 factorial, that is 4 into 5 into 6 divided by 3 factorial is nothing but 1 into 2 into 3 into 1 by 2 whole to the power 6 is nothing but 1 by 64. Digital electronics. Okay, so this is 2 into 3 and 6 gone. So 20 by 64. Your answer is 20 divided by 64 divided by 4, 5, sorry 4 you will get 5 divided by 16. So your option D is correct. So please remember this formula from this question. Probability of reaching the destination which is m step away by taking n step is n factorial by n plus m by 2 factorial into m minus n by 2 factorial into 1 by 2 whole to the power n. Now when m equal to 0, this probability is maximum. Maximum probability is when m equal to 0. Which of the following gives statistical definition of temperature in terms of microstate omega? Now a system is said to be in equilibrium when it has attained thermal equilibrium, mechanical equilibrium as well as chemical equilibrium. Thermal equilibrium means temperature is constant. Temperature, or you can also write beta constant. Beta means 1 divided by kBT. So this is how you test the thermal equilibrium. Beta equal to dou by dou E of log omega. That is nothing but 1 divided by kBT. So 1 by T is equal to kB times dou by, instead of E you can write U log omega. That is U is nothing but energy. So from the question your option A is correct. Now for mechanical equilibrium you can write eta, that is equal to dou by dou V of log omega. This is to test mechanical equilibrium, and this eta is equal to pressure by kBT. Pressure by kBT. This is for mechanical equilibrium. Now for chemical equilibrium you can write zeta equal to dou by dou n. Dou by dou n. N is number of particles of the state, and log omega. Dou by dou n of log omega. And eta is given by, eta is equal to mu by kBT. So beta equal to 1 by kBT, eta equal to P by kBT, and zeta equal to mu by kBT. And what is mu here? Mu is chemical potential, and P is nothing but pressure. So these are the different standards for measuring equilibrium: thermal equilibrium, chemical and mechanical equilibrium.